Okay, so let's try this. So we have a path of a satellite orbiting the Earth causes a satellite to pass directly over two tracking stations, A and B. So on the Earth, I'm going to have two tracking stations. I'm going to have A and B, and they are 50 miles apart. Measures taken before the satellite reaches either station, so my satellite is still back here somewhere, shows that the angles of elevation to A is 87 and to B is 84. So this would be 84. Angle of elevation is again coming up from the horizontal. So this is actually going to be 87. And I want to know how far is the satellite from station A. So I want to know this. Well, first off, let's get all my angles to be in the triangle. So if this is 87 and this is a straight line, because again it's a horizontal, then this would be a straight line is 180. So 180 minus 87. So that should be 93. Okay, and I could probably just fill in the other one in my triangle just to be safe. So 93, well here, 93, 84, 7, 177. Ooh, so this is only a 3-degree angle. That's a pretty small angle up there. So I at least filled in everything, and now I know I'm looking for this. So I could use, I guess, law of sines, or I could, I guess, use law of cosines. Again, law of sines is opposite. So since we do have angle and opposites, it's going to be easier for us to use law of sines. Always choose law of sines if you can, because it's less to remember. So if I look at this, I have a side and the angle opposite, and I have the side I want and the angle opposite. So I can set them up in ratio. So sine of 3 over 50 is going to equal sine of 84 over x. If I solve for x, I'll clear my denominator, so multiply by 50x. So I'll get x sine of 3 equals 50 sine of 84. I don't know the sine of 84. I don't know the sine of 3, so I'm just going to solve for x, and then I would use a calculator. 50 sine of 84 over sine of 3. Okay, so that is how far this thing is. This thing is 50 sine of 84 over sine of 3. Other thing I want to know is how high is that satellite above the ground? Well, if I drop it straight down, drop a vertical, that's going to be how high it is above the ground. And if I look here, I know that my angle here is 87. And I actually already know this side. That side is 50 sine of 84 over sine of 3. That side was x. So I could just do, basically, what do I have? I have an angle, I have the adjacent, or I have the hypotenuse, and I'm looking for the opposite. I'm looking for this time. So this one I was looking for x, this one y. So I have an angle, I have the opposite, and I have the hypotenuse. That means sine. So sine of my angle, because now I have a right angle, I can just do regular sine, equals opposite. So my opposite was y over my thing I found in a previous problem. 50 sine of 84 over sine of 3. How would I solve that? Well, solving for y, I'm just going to multiply by this monstrosity down here. So I'm going to get 50 sine of 84 degrees times sine of 87 degrees all over sine of 3 degrees equals y. So I can use the law of sines when I don't have a right angle. And it was easy to use law of sines this time. I could just set up a ratio. But if I have a right angle, I can then go ahead and just use what sine means or what cosine means.